Hello everyone. In this recording and the next three remaining recordings, we try to solve exercise 1, which is hiking trip using exhaustive search algorithm. So the problem says that we are preparing for a hiking trip and can only carry a backpack of limited capacity. Each item has a weight and a value or importance. The backpack capacity is 15 kilograms, and here is the list of available items, their corresponding weight and also value. So the task is to implement an exhaustive search algorithm to find the set of items which maximizes the total value without exceeding the weight limit. So what we need to do is to implement the exhaustive search. So if we go back to the, the lecture that we had, is this exhaustive search algorithm. You can see that after receiving the input from the user or giving as an input, then we are going to have a for loop that we generate possible solutions, each possible solutions at a time. And when we generate that possible solutions, S, we check the feasibility of that possible solution. And then if it was feasible, we check if it is better than the best possible solutions that we have found so far. And if it was better than the best, so we replace the best with the one that we found right now, both for the objective function and also the solution. So this is the pseudocode or the actual or the algorithm that we have for the exhaustive search. So, but what I'm trying to do in this video and also the next two ones is to separate those three uh, uh, functions or actions. So in a way that first we try to generate all the possible solutions without checking their feasibility. And the next step, we check all the feasibility of all those generated possible solutions. And in the third step, we try to evaluate the objective function of the feasible solutions and compare them and find out the best among them. And in the first video, I try to merge those three parts to actually follow what we have in this slide as the pseudocode of the exhaustive search. Okay, so going back to the PowerPoint, our goal here is to generate all the possible solutions. So we know that we are going to use the binary representation for that knapsack problem. And if we go here, using the binary representation, our solution is going to be something like this: a vector or a list of zeros and ones, and the number of the total number of possible solutions equals 2 to the power of n, which n is the number of items or elements that we have. So let's say we have 3 elements or items in our problem, and therefore we have 8 possible solutions. So how we are going to generate those 8 possible solutions? So let me first have all the solutions here. So starting from the easiest one is we can say we have 3 zeros. So this is an initial solution which is easy to generate, so we can call it the initial one. And then how I can change and produce the next possible solution is by changing each of those zeros to a 1. Okay, so I'm going to repeat this one. And so if I'm going to change this one to 1, this is a new possible solution. in the next step, I'm going to change this one to 1. So this is another possible solution. And then I'm going to change this one. Then I can convert, let's say, these two together. Okay, this is a new possible solution. And this time I'm going to change this one and this one. And how many solutions do we have? 1, 2, 3, 4, 5, 6. Sorry, 3, 6, 7. This is the 7, so I'm going to change this one to 1 and also this one to 1. So we have 7, and the last one should be all of them equal to 1. 1, 1, and 1. Okay, so this is all those 8 solutions, possible solutions that we can have. Okay, the point is here that these solutions are, since they are binary representation, they are equal to, if we imagine them as base 2 numbers, they have a representative in the real numbers based on 10 base. So for example, this one is equal to 0 in the real numbers that we have. Or for example, this one equals to 4. This one equals to 2. This one equals to 1. This one equals to 3. This one is equal to 5. This one is equal to 6. And this one equals to 7. So if we look at them, all the possible solutions that we could have are corresponding to, or we can say they have a representative in the 10 base numbers, and they are actually from 0 to 7. So it means that we actually need to treat them as numbers and try to add them one by one, add them one at a time to generate a new possible solution. So for example, in this case, this is 0, our initial solution. If I add 1 to this 0, this is going to be the next solution. And then if I add this, another 1 to this one, is going to be this one, which is the third solution, okay, equals to 2. But the problem is that we couldn't tell our code that, okay, take this, treat it as a number, add 1 to this number, and then give me a new possible solution. We need to find a way to generate those numbers which are the same as our possible solutions at a time, and save them, print them, or store them somewhere so we can check their feasibility in the next step. Okay, so in the next step, what we need to do is find a way to go through 0 to 1, 1 to 2, and so on. So let me sort them. I'm going to pause the video, sort them so we can find an algorithm together. Let me. So okay, now I sort them together, and now we wanted to see how we can have an algorithm to generate those possible solutions. So if I want to go from 0 to 1, and if I treat them as numbers, so we know that, for example, when we want to add 2 numbers in 10 base, we start from the far right digit and we add them together, and if they go beyond 9, so we have the remaining out of 10 as the far right digit, and we add 1 to the digit on the left. Okay, so this is how we add 2 numbers in 10 base. So this is the same case in 2 base. So we have this 0. If I add 1 to this 0, this 0 is going to be 1, and so we have the next one. Then I have to add 1 to this number. And if I add to this number, because 1 is the largest digit that I can use in 2 base, so this is going to be 0, and then I have add 1 to the digit on the left. Then if I add 1 to this number, this 0 is going to be 1, and we have the next. And for this one, if I add 1 to this, it's going to be 0. I need to add 1 to the digit on the left. Since it's 1, and I couldn't add to this one, so this is going to be 0, and therefore I'm going to flip the last digit to 1. So we have 4, and the same thing happens till we get 5, 6, and 7. So what you see here, that whenever we reach to a 0 digit, we flip it to 1. In this case, we reach this one, we flip it to 1. In this case, if we reach to this 0, we flip it to 1. In this case, when we reach to the 0, we flip it to 1. In this case, when we reach to the 0, we flip it to 1. So every time that we see a 0, we flip that digit, or we change that digit from 0 to 1. Okay, so, and we start checking from right to left as we do in typical addition that we have. Okay, so this is the first step, or the first rule. If it is 0, change it to 1. If it is 0, change it to 1. If it is 0, change it to 1. And if it is 0, change it to 1. But what the other rules? In this case, that we have 1. So when we have 1, which means that if we add an odd 1 unit to this possible solution or number, this digit should be 0, because we don't have any greater digit than 1 in base 2. So when we have 1, we should make this one 0, okay, and check the digit on the left. When we have 1, we have to make it 0 and check the digit on the left. When we have 1, we have to make it 0. So you see, whenever we have 1, the next possible solution, or the next number's digit at the same index, is equal to 0. Okay, so this is the other thing that we have to have in mind. So there are actually 2 rules. So when we reach to the 0, we change it to the 1, and if it is not 0, which means it is 1, because we have only 2 numbers, then we make that 1 equal to 0. Okay, so let's go to the Colab and try to generate all the possible solutions. So let's say we call this one as a text, and generating all possible solutions. So solutions, and then I'm going to ask the user how many inputs we have. So I define variable n, and I ask the user using the input function how many items do you have. And so this is the input function. We use the input function to ask users for his or her answer. And because the output of the input function is always a string, so we need to convert this string to integer, because we need to treat this n later as a number. So we don't want it to be a string, because if it is a string, we couldn't add it, or we couldn't use it in our problem later. So we needed to convert to an integer. And then, sorry, and then we have the first solution, or the initial solution. I'm going to call it the solution. And as you see, the easiest way is to generate a list, or a vector of zeros. So in our case, we have this thing here. So this is a list that has one item or one element, which is 0, multiplied by n, which is the number of items or the length of the total items that we can have, which is equal to 6. So the solution, so the output of this these two lines of code is going to be a vector or a list of zeros. So if I print solution and run this line of code, delete n. Okay. So first it asks how many items do you have? Let's say we have 3 items, and here is the solution, 3 zeros, which is our initial solution. Okay. So when we have, now we have this initial solution, and we have the number of items that we have, so we can go through, we can generate our other possible solutions. So if we assume that n is equal to 3, we have 8 solutions. So we need to generate 8 different solutions. So we need a 4 here. So we have 4 I in range of, and so what is the range here is the total number of solutions is n to the power of 2 to the power of n. So when we have 3 items, we have 8 solutions. So this is 2 to the power of n, which is equal to 8. Instead of that, you can also use the POV, the power function in Python. So this is, it has 2 parameters. The first one is the base, and the second one is the actual power. So the answer to this one is also equal to 8. And if you also have this one, 2, 3, it should also be equal to 8. Take some time, and okay, yeah, here we go. It's equals to 8. Okay, so now that we have this one, so each time that we generate the solution, we need to print it. So we print the solution. When we print the solution, now that we have our first solution, initial solution, we print that initial solution. What should we do next? Generate the next possible solution. We remember that what we did here, we start from the index or the digit on the far right, and we also have 2 rules. When we have 0, change it to 1. When it is not 0, which means it is 1, to have the next possible solution or the next number, you need to make it 0 and look at the next the digit on the left. And again, the same rules. If it was 0, change it to 1. If it is 1, make it 0 and look at the digit on the left. And here is, for example, the sample. So we see this one, it's equal to 1. Okay, what is the rule? Change it to 0 and look for the next item. Again, what are the rules? Check this one. It's 1, change it to 0, look for the next item. Again, the same rules. Is it 0? Yes, change it to 1. So this is so we have 2 rules. For each digit, check it. If it is 0, change it to 1. This is the end. You have a new possible solution. If it is 1, make it 0, go to the next digit on the left. Okay, so these are the only 2 rules that we have to play with to generate all the possible solutions. So now that we have the solution, we need a for loop to go through all the items or all the elements that we have in the list. So for I in range of, and so for the range we have this part, we can also have 3 different inputs, or 3 different parameters. So the starting point in our case is it's far right, and which means the last digit. So if we look at here, indexing starts from 0, 1, and 2. So we are looking for this one. This is 2, which in our case equals to n minus 1. So we go back here. So this is n minus 1. And what is the last digit or the endpoint of this loop? We know that for range, the last digit always excluded. So in this part, 2 to the power of n is equal to 3, which means 8 is excluded. Here, we want to go from 2 to 1 and 0. So the endpoint should be -1 to make sure that we go through the index 0, and also we are moving backward. So the step is -1. Okay, so this is the 4, and again now we are going to write our 2 rules that we have. So first we check if solution index I is equal to 0. If it is equal to 0, the rule is to change that solution to 1, and then you are done. You have a new solution. Get out of this loop. You are done. Go and print that solution. So we use break. Sorry. We use break, and with this break we are out of this for loop. We go to this outer loop, and so we can print our new solution. Okay. If this is not the case, which means that the solution index I is not 0, which means it is 1, then what was the rule? Change it to 1, go to the digit on the left. So solution I, make it 0, and then because we don't use the break here, because this statement is false, so we make it 0 and we go to the next I. I was 2 before, now I is 1, which means the digit on the left. So we go here, check this one. If it is 0, make it to 1. You have a new possible solution. Break, get out of this loop. Okay? If it is 1, make it 0. Go to the digit on the left. It was 2 previous, then changed to 1. Now it is going to be 0. So the 0, is it 0? Change it to 1, you have a new solution. If it is not, which means we had 1, 1, 1, then this is the end, and actually the I is going to be out of the range of 8, so we are out of this outer for loop and we are done. Okay, so this is the for, and when the for loop is done, what we are looking for is the solution. So I'm going to print the solution sorry, we had to print. Sorry, we don't need to print the solution. It's going to print the solution here. So everything is done. So we are going to run this code. How many items do we have? We have 3 items, and here are the solution. 0. We change this one to 1. So if we look at from their number in 10 base, this is 0, this is 1, this is 2, 3, 4, 5, 6, and 7, and we have 8 possible solutions that we were looking for. So the only change that I want to make here is because now we are printing every time the solution, I want to define a new list and then store all of those generated possible solutions in that list. So in the next step that we want to check their feasibility, we could have access to each one of them. So instead of printing here, and before that, I need to define that list that I told you, and I'm going to call it the possible solutions, and this is going to be an empty list. And instead of printing the solution every time that I generate a new one, I'm going to simply append that new solution to that list that I generated. But we are going to use the copy to add the actual generated one to the solution, because if I'm not going to use the copy every time, it referred to the solution that we had here, so it's going to be always 0 0 0 0 0 0, and there's no change in the solution. So here's the thing, and then by the end of this loop, now in this lines of code, I need to print the possible solutions, see what are those possible solutions, and also I'm going to print the length of that list, so we can see how many solutions we actually have. So if I run, it's going to ask how many items. We have 3 items, and here is the list of the solutions that we saw before. They are exactly the same, and their sequence is also the same. And here is the 8 that we are looking for. If I run this one more time with the actual problem, because in the hiking treat we have 6 items, so 6, and here we have those um, uh, 64 possible solutions, 2 to the power of 6, which is 64. And let me go somewhere and see if it applies our rule. So if you look at this one, we always start from this index. Okay, so when we print this one, we go back here, so the index is the n minus 1. So what is the n minus 1? It's 0. What is the rule? Is it 0? Change it to 1. So that's why the next solution is exactly this one, but flipping this 0 to 1. And without looking to the next solution, if you are looking this one, and we always starting from the far right digit, we are checking this one. Is it 0? No. Change it to 0, look for this one. Is it 0? Yes. Change it to 1. Now you have a new solution. And here is this one. The first one is 0. Sorry. This one is 0. This one is 10, which is actually following the rules that we discussed before. Okay. So here is the end of this video. In the next one, we try to check the feasibility of all of those possible solutions, and in the third one we evaluate their objective function, and finally in the last one we merge all of those 3 separate parts together and see the exact representation of that pseudocode in Python. Hope you enjoyed, and see you next time.